This lecture is entitled An Astronomer's Toolkit and corresponds to the fourth and final subsection of section 1.1.
Now we're up to measuring the universe. Of course, we can't use yardsticks to measure the distance to a star or to a galaxy. All we get from these are light. So a lot of this course will be about how we can use light that we collect in telescopes to figure out the distance and the composition of stars and galaxies.
The tools of ancient astronomy were limited to eyes for observation of visible wavelengths and alignment tools for determining positions. In the 1600s, lenses were used to make the first telescopes, and Galileo's observations of the sky with his telescope changed the world's cosmological views. In 1957, the Soviet Union launched Sputnik, the first human-made satellite. With the ability to place instruments in space, knowledge acquired by astrophysicists exploded. Astronomers collected information from multiple wavelengths, from the highest energy gamma rays and X-rays through ultraviolet, visible, infrared, and radio waves. For this reason, it is important to look at the caption of images in the book to determine what wavelengths contributed to the data. In the case above, figure 1.5, the Milky Way galaxy is imaged in radio wavelengths, which is why the R is bolded.
We'll be using telescopes, the International Space Station, and other space-based telescopes. Here are some images of astronauts in the International Space. The International Space Station is, of course, one of the most expensive projects in science ever taken by the world, and the whole world is involved. We have Curiosity rover, where we can't send people yet, but we're hoping to in the future. We have rovers that run around and they're robotic geologists exploring foreign terrain. And to have communication between all of these different satellites and rovers and space stations, we have a deep space network, radio telescopes in Madrid, Spain, in Goldstone, USA, and in Canberra, Australia. And you can always go to this website, Deep Space Network Now, and see who's talking to NASA right now.
In summary, modern astrophysics use telescopes and digital cameras to collect imagery in many wavelengths and require computers and storage devices for data analysis, modeling, and simulation. Satellites carry equipment and even people into space to conduct experiments and gather observational data.